We're going to do a new problem. You ready?
Yep.
Okay, the average BMI for dogs is 17 with a known standard deviation of 3. This was found from a sample of 64 dogs. Compute a 95% confidence interval for the mean. Okay, computing 95% confidence interval for the mean. So confidence intervals are simple, right? They're simply the mean plus or minus z alpha by 2 standard deviation square root of n. Which in this case, what's the mean? 17 plus or minus z alpha by 2. That'd be 1.96, right? So everyone know how to get that? Okay, if we're confused, it's right here. This has to be 95. So that means that z-score is inverted norm 0.025, and that is 1.96. If you want to check.
Is that z-score divided by 2?
Yes. No, it's not the z-score divided by 2. It's a z-score for alpha divided by 2, where alpha, half of it's here, and half of it's over here.
What does that say?
Inverted
Invert norm?
norm 0.025. That's how you find that value. We want a 95% confidence interval. That means this area has to be 95. So it means 1 minus that split over here. So this is 0.25. This is 0.25. So this is my z-score alpha by 2. This is my other z-score alpha by 2. So how do I find that? Inverted norm 0.025. This one is inverted norm 0.975. So this is 1.96. This is negative 1.96. Okay? So that's how you find them if you don't forget. Okay? So what's the standard deviation? Standard deviation is 3. What's n? N is 64. So square root of 64 is 8. That's 3 over 8. So that's 17 plus or minus 1.96 times 0.375. And that's going to be 17 plus or minus 0.61 or 0.71, 0.73, something like that. What is it? 1.96 times 0.375 is probably 0.73, 0.74. Does anyone get that? .735. So I simply add 0.735 and I subtract 0.735. So that's 17. This is 17.735. This would be 16.265. So that is my 95% confidence interval. I'm sorry?
Like, how'd you get the answer?
Okay, you add and subtract this. So when you add 0.735, that gives you 17,735.
So what?
When you to the mean, because we're putting a confidence interval about the mean.
Oh, I see what you're saying.
The mean is 17. Okay, same problem, except now we're not sure the standard deviation is known. And our sample size is 16. Compute 95% confidence interval.
T-table time.
Okay. What's that?
T-table time.
Yeah, that's right. Everyone okay with that? Everyone get the notes there? We are not sure the standard deviation is known, and our sample size is now only 16. Compute a 95% confidence interval. Okay, well, here's where you have to be careful. The confidence interval is now mean, or the average, I should say, the average, plus or minus t alpha by 2, standard deviation, square root of n. Right? So everything's the same between those two formulas. The only difference is what? We have to go to the t-table to find our key value. So when we go to the t-table, we're looking at 95% confidence interval column, degree of freedom, don't forget, n minus 1, so in this case it's 16 minus 1 or 15. So we're in the 15 row, 95% confidence interval column, and what's that value that we find? Here, degree of freedom, DF, degrees of freedom. That's the left column in that table. Okay? You okay with that? So we're in the 15 row, 95% confidence interval column. Make sure you get the right column. Row 15, and what do you find?
2.131.
2.131. If you went all the way down to the bottom of that column at row 30, what would the value be? I'm just curious what it is. What is it?
2.042.
Yeah, it's almost 1.96, isn't it? 2.04 is almost 1.96. That's what I was saying. When n gets to 30, it converges to the same thing. Okay? But when n's small, it is a little bit greater. 2.1 is a little bit greater than 1.96. So what would this be? It would be 17 plus or minus 2.131 times the standard deviation, which is 3 by the square root of 16. Be careful to get the revised n. In this case, it's 17 plus or minus 2.131 times 3/4. It's be 17 plus or minus 2.131, 0.75. And what's 0.75 times 2.131?
So you don't divide by 2, or you do divide by 2?
Oh, no.
You get the number off the table.
No. It has a column there for confidence intervals. It's already done all that for you.
0.75 times 2.131 is 1.5, or 1.6, I guess.
1.6. So 17 plus or minus 1.6 would be 17 plus 1.6, and that would be 18.6. Be 17 minus 1.6, and that would be 15.4. So a 95% confidence interval, when we reduce our sample size from 64 dogs to 16 dogs, goes from 16,265, 17,735 to 15,4, 18,6. So it's going to be a broader net. We want a broader net.